All right, so section 10.4 is on exponential and logarithmic equations and inequalities. So an exponential equation is exactly what it sounds like. It's an equation containing one or more expressions that have a variable as an exponent. So in order to solve an exponential equation, you can do three things. So one, if you can get your equation in the form a to the x equals a to the y. Do you guys see how you have the same base? So it's a number to something equals that same number to something else. Doesn't it make sense the x and y would then be equal? So then you can just say x equals y. Okay, this is the easiest way, but it only works when you have the same base. Okay, number two, you can take the logarithm of both sides in order to drop the exponents. And three, you can switch to logarithmic form. Okay, so number one, it says solvent check. So if I have 9 to the x, or 8 minus x equals 27 to the x minus 3. 9 and 27, you can get those to have the same base. Do you guys see what they have in common? One's, yeah, not 9, like it's not 9 to a power. But see how you could say this 9 is 3 squared and 27 is 3 cubed? So I'm going to change 9 to 3 squared. And I'm going to change 27 to 3 cubed. Okay. So 9 was 3 squared, 27 was 3 cubed. Okay. Now, I know that if I have exponents and I'm raising an exponent to another exponent, you multiply. So multiply your exponents. So I get 3 to the 16 minus 2x equals 3 to the 3x minus 9. Okay, so I have 3 to some power equals 3 to another power. So if they're equal, that means those powers have to be equal. So you can just say 16 minus 2x equals 3x minus 9. Add your 2x to the other side, so I get 5x. Add the 9 to the left side, so I get 25. So I get x equals 5. Okay, you can go back and quickly check. If you plug 5 in, you get 9 to the third equals 27 to the second. And if you check those on your calculator, 9 to the third is 729, 27 to the second is also 729. So it does work. Okay, next one. So if I have 4 to the x minus 1 equals 5. All right, do you guys see this is different than number 1? Number 1, you could make both of them 3 raised to something, 3 raised to something. 4 and 5, you don't have them having, you can't get them to have the same base. Do you see what I'm saying? So you can't get them to be the same base. Okay, so you can take the logarithm of both sides, or you can switch to logarithmic form. So let's switch to log form. Okay, so a lot of you guys are getting really good at this. So if you have log, the base of the exponent is the base of the logarithm. So the 4 goes down there. You put the 5 next, right? Equals x minus 1. So that way we have 4 raised to the x minus 1 equals 5. Okay, well, log base 4 of 5. I can't put that in my calculator exactly like that. What do I need to do? Yep, change base. So I get log of 5 divided by log of 4 equals x minus 1. So I can find what those are. So do log of 5, and then divide by log of 4. So when I do that, I get 1.16096 equals x minus 1. So I'm just going to add the 1 to both sides. So I get 2.16096 equals x. Okay. Usually my general rule is, since I teach AP Calculus later, AP Calculus always rounds to 3 decimal places. So that's usually what I'll have you guys round to. So if you guys want to write this as 2.161, that could be your answer. Okay. Some teachers are really mean and they make you leave the logs in. I'm not going to make you do that. Like they would have you write the answer as log of 5 over log of 4 plus 1. So you can find the decimal version. Mr. Syrick says he's mean and makes you leave it in. right, next one. So if I have 7 to the negative x equals 21, so let's try this one the way we just did. So go ahead and try to switch to log form. So you should get log base 7 of 21 equals negative x. So once it's in that form, I'm going to do change of base. So I see it's log of 21 over log of 7 equals negative x. Okay, so log of 21 divided by log of 7. So I get 1.56458 equals negative x. So that means x is just the negative of that. So I'm going to be lazy and just write x and then negative. Okay, so if you round to 3 decimals, it'd be negative 1.565. Make sense? Okay, let's try this a second way. Okay, so the other way you can do this is you can start with your 7 to the negative x equals 21. And you could take any logarithm of both sides. So it doesn't matter. It could be natural log, log base 7, whatever you want. So let's say we do log base 7. Okay, do you remember last time when we were taking notes and we had things like log base 3 of 3 to the 11? What was the answer? 11, right? You just got rid of the log base 3 and 3. That's what's happening here. The log base 7 and 7 are canceling. So you get negative x, right? Okay. Did you guys notice this is the same step as what we had right here? So same from there on. So just etc. Okay, so that's one way you can do it. Third way. Don't you like all these different ways? It can be good and bad to have all these different ways. All right, so if I have 7 to the negative x equals 21, like I said, you can use any logarithm that you want. So we haven't talked much about natural log, but let's say I took natural log. So I do ln on both sides. Don't say line, that drives me crazy. Natural log. All right, any logarithm, as long as you have the logarithm, you can pull the negative x to the front. That's the convenience of having logarithms. It allows you to drop exponents. So I get negative x times natural log of 7 equals natural log of 21. So I get negative x equals natural log of 21 divided by natural log of 7. And that's the same thing as what we had over, do you see where I'm circling? Right here. Because when I do my change of base formula, I can change it to any base I want. It could have been log base 5. It doesn't matter. So natural log of 21 over natural log of 7 is the same as log of 21 over log of 7, or log base 5 of 21 over log base 5 of 7. Okay, so find what that is. You get the same thing. Okay, so 3 different ways. All right, so number 4, it says suppose a bacteria culture doubles in size every hour. How many hours will it take for the number of bacteria to exceed 1 million if you start with 1? This is kind of like your homework problem. So if you think about it, after the first hour, you only have 1 million. Only. Or no, after the first hour, you have 1, right? So 0 hours, you have 1. So after 1 hour passes, you have 2 bacteria. After 2 hours, you have 4 bacteria. After 3 hours, you have 8, so it's doubling in size every hour. So this one was that 1 times 2 to the first. This one's 1 times 2 to the second. This next one's going to be 1 times 2 to the third. Okay, so your formula is your amount after t hours is you started with your principal, which was 1, and your rate that you're, not the rate, but the 1 plus r is 2 raised to the t. That's why on your homework, remember you guys were trying to use that formula, p times 1 plus r to the t, and I was telling you r was 1 because it made 200% inside here. You were adding 100% of what you had before. All right, so here's your formula. Because in parentheses it was 1 plus 1. That's what's going on here. It's 1 plus 1. Okay, so I want to find when it's equal to 1 million. So 1 with 6 zeros. 1 times 2 to the t is just 2 to the t. Okay, so solve it any way you like. Which way did you guys like up here? Log over log, this one? Yeah. The first one? Okay, so you can switch to exponential form, or switch to logarithmic form. So it's log base 2 of 1 million equals t. So 2 to the t equals the 1 million. Okay, but now once I see that, I know I can't put in my calculator with base 2, so I change it. So it's log of 1 million divided by log of 2 equals t. Does anybody find it? Yep, 19.932 hours. So it took almost 20 hours for it to reach 1 million. Which is kind of gross if you think about like your pizza laying out on the counter. So in 20 hours, that one bacteria is now 1 million. I won't get all germy on you. All right, next up. Okay, so those were all exponential equations. Those all had exponents. Now we're going to talk about logarithmic equations, so equations with logarithms. So it says, like exponential equations, if you get a logarithmic equation in the form log base b of x equals log base b of y, you can say x is equal to y. You can also switch from log form to exponential form. Okay. So this one, I have log base 6 of 2x minus 1 equals negative 1. So whenever I have it set up in this form, a log equals a number, it's just easy to just switch it to exponential form. So do you guys remember switching? 6 raised to the negative 1. So 6 to the negative 1 equals 2x minus 1. That's why I was telling you guys, if you don't know how to switch from log to exponential, your test will be a disaster. So you need to know. All right, 6 to the negative 1 is 1/6 equals 2x minus 1. Okay, I'm going to add my 1 to the other side, so I'm going to have 1/6 plus 1 equals 2x. So 1 is 6 over 6. So 6 over 6 plus 1/6 is 7/6 equals 2x. Okay. I get rid of my 2 by dividing by 2. In other words, that's the same as multiplying by 1/2. So your answer is 7 over 12 equals x. Okay. All right. How about the next one? We don't have just one log. Is there a way to get it to be one log?